Alright, so here's our review for summative number 4 in Algebra 2, and this first section is a repeater section from the last test. So you guys did actually a very beautiful job of using your calculator to find the pertinent parts. So the polynomial here, you're going to want to type this into y equals. Y1 is where mine's located, so I already have this typed in. And then they're going to want us to find the x intercepts, and apparently there are 3 of them. So notice I have a lot of other things in my y equals, but they're all turned off because they're some upcoming questions. So y1 has the polynomial put in. I'm going to hit zoom 6 to make sure I have a standard viewing window. And yep, I can see all 3 x intercepts. 1, 2, 3. Unfortunately, they're not going to be nice numbers, so I do have to use my calculator to find them. And I'm going to choose to find this x intercept first. So it's approximately at like negative 0.7, I'm going to say, but I'm going to find it exactly using the calculator. So using the zero finder, you're going to either drag it to the left, or I'm going to have to hop to a time before the x-intercept occurred. So I'm going to go to -1. That's definitely before it. And then I need to go to a time after it, or you can drag your cursor to the right of it. So I'm going to go to 0. That's definitely after it. And then enter one more time when it says guess. And yeah, pretty good guess. So negative 0.66, comma 0. So let's go to the hundredths place on this. Negative 0.66, comma 0. And if we're writing some notes to ourselves, the zeros is in the calc menu. So you go to second trace. And then you're choosing number 2. Zero finder. Alright, we got to do all that over again on the calculator to find the 2 x-intercepts that we haven't found yet. Where'd you go, buddy? Alright, so same command, second trace, number 2. This time the x-intercept appears to be at like 1.5-ish. So something before it would be 1. Something after it would be 2. And then enter one more time when the guess comes up. Alright, so a little bad guess on mine. It's 1.33. Oops, where'd you go, buddy? There we are. So 1.33, comma 0. And then that last one, we do have to find that last one. So same command, second trace, find the 0. It's approximately at 1, 2, it's right before 3, so it's like 2.9, 2.8. So something before it would definitely be a 2. And then something after it, I'm going to go a little bit further than normal. I'm going to go to 4 just to make sure. And then enter one more time. Alright, pretty good guessing. 2.84. So, those are all the x-intercepts. And I'm going to want to plot them over here, which, yeah, good luck. You know they're going to be awful. Oh, that wasn't even close. Oh boy. Okay, so that's great. We're not going to use those numbers anymore in the problem. Now we're going to find our maximum and our minimum, and if I remember correctly from this graph, it did have one of each. So first, let's go find this maximum value. You might be able to estimate it off the graph, but I want an accurate answer from the calculator. So this time you're going to choose the maximum finder. And I'm guessing that it's around 0, like x equals 0, but if I do a time before it, something before it would definitely be like -2. Oh yeah, way before it. Alright, and then something after it, I'm going to go with 1. And then enter one more time when it says guess. This time you do need to write the whole ordered pair. Oh, I'm glad I didn't assume that was at 0 something, because it's not. It's at 0.15, comma 5.15. So your maximum is 0.15 and then 5.15. So this was, again, second trace, but you chose number 4, the maximum finder. Now we're going to have to find that minimum, which means we're going to choose, I think it's number 3, the minimum finder. And that's this guy down here, which is approximately at x equals 2. So I'm going to keep that in mind when I go to guess. So second trace, this time we're finding a minimum. Okay, so a time before the minimum occurred would be like a 1. For sure that's before. And then something after it for sure would be a 3. And then enter one more time. So 2.18, comma negative 3.19. 2.18. And then negative 3.19. Now I should be over here plotting them. You know I'm a lost cause for plotting though, guys. This is going to be so bad. And then this 0.15. Oh boy, 5.15. Yeah, sure. Now, I'm supposed to come through and draw the... Oh boy, that just gets worse and worse the more I do. Okay, so that's my rendition of that polynomial. That was really bad. Okay, here's something that I think we could all improve on. I'm going to ask you for the increasing and decreasing interval. What I want you to try to do is to remember that if we use highlighters, I think we'll alleviate some problems we had last time. So I'm going to choose my highlighter and I'm going to highlight the x values from my maximum and my minimums, because those are the times where your roller coaster, remember, switches and turns from increasing to decreasing or vice versa. So remember how I have this horrible graph over here. I'm going to draw like another version of it over here. And on here, I'm going to mark like the times, the things I just highlighted. So this is like 0.15 and this is 2.18. So when they ask me for when is this increasing, well, this right here is an increasing roller coaster track, right? And so is this. So an increasing interval starts at negative infinity, like all the way to the left, it's increasing. But then it turns around once it gets to 0.15. And then there's another time when it's increasing, it starts at 2.18. But then it goes forever to the right, so it increases for the rest of the domain. Decreasing would be this little downhill part right in the middle. And that starts at 0.15 and then stops at 2.18. So there's your increasing and decreasing intervals. I think if we start using our highlighters and highlighting the numbers that we're supposed to be using and really acknowledging that, I think that'll relieve some stress from some of your testing. Last time, you guys had a really good handle on intervals. Unfortunately, some of you used the y values instead of the x values, so that was a bummer. Don't do that. All right, the next one I'm going to leave for you to do. I will give you a little heads up. Obviously, you can just check the answer key, but you're going to need a calculator to find these two things. So you can use your app if you have one of those Wabbit emulator apps. Otherwise, you can just look at the key. I think the increasing and decreasing interval part of the question is where most of us struggled last time. There is no longer going to be an end behavior question on that particular question because end behavior is coming up on the next section anyway, so we just kind of left it off of that one. All right, this is a new section. We've been working hard with our calculators, looking at exponential growth and decay functions. And the first couple are really theory questions. This is a 2/3, I think. So we have 2/3 raised to the negative x power, and the first question is, what is the base? Now this is a trick question. This is very much designed to trick you. So be careful. The base is not 2/3, because this is really 2/3, but it's got a negative x exponent, so it's like 2/3 to the negative 1, and then it's raised to the x after that. So the base is really, when you have a negative 1 exponent, remember, it's going to distribute to both of them and it's going to reverse the fraction. Or you're going to get the reciprocal. So the base is actually a 3/2. Okay, so be careful there, it's a trick question. Now 3/2, remember, that's approximate, well, it is exactly 1.5, right? So the question is this growth or decay? It is growth because the base is 3/2, which is greater than 1. So be careful. Your explanation, remember, I need a big kid explanation on that question. You can't tell me a little kid thing like it goes up or it goes down. That will not be counted correct. All right, so try those. This next question here, I covered up half of it. What does it say? We have this function. Oh, and we're supposed to write a new function that has been shifted right 2 units and then up 9 units. So if I think about this new function, which they want me to call g of x, I think. Originally it's 7 to the x power, but in order to shift right 2 units, that's going to be looking like that, isn't it? X minus 3 is how we shift to the right through. Oh, that's not 2. X minus 2 is how we shift right 2 units. Remember opposite signs for those. If you want, you could put parentheses around this. You don't need them though. And then up 9 units would be a vertical shift off to the side like this. So obviously you don't need the parentheses. Some of you just wrote down 7 to the x minus 2 plus 9. That's fine. That's actually a better answer than what I originally wrote down. Be careful about notation. Make sure the x minus 2 is a component of the exponent. Okay, there's another one there. Please practice those. And then we're going to get to graphing. All right, so you have, right away without graphing it, you should be able to answer this for me. The base is 5/4. Which, be careful, that is a number that's bigger than 1. That's like 1.25. So because of that, you have an exponential growth. The next question, I'm also kind of hoping you can answer without really grabbing the graphing calculator, because we know that any vertical shift is going to move the horizontal asymptote location. So if your vertical shift is down 4, that means your vertical asymptote, sorry, not vertical, horizontal. All right, your horizontal asymptote is also going to be at down 4, which is y equals -4. Why does that look so sloppy? Then, from here, you might want to go ahead and investigate some calculator work. I'm going to use my highlighter again, and since I know the asymptote line is at -4, I'm going to go ahead and draw a little highlighter line there, and it's going to help me with my graph, because I need all the help I can get. You're going to type your function into y equals. Remember, I have some weird stuff going on. I am going to turn this one off, or not. There we go. This is a trick you can do if you're ever like, don't want to delete all your functions because you need them for later. You can turn them on and off by highlighting the equal sign. All right, I'm graphing this new guy now. Hit graph. There you be. Lovely. And then I want to go to the table and graph a few good points. I mean, there's not many. The asymptote line is not a really great place to start plotting. But, you know, these few here, maybe graph some of those. Okay. Since I can't graph to begin with, I'm not really too concerned about this. I did recognize that it went through, I think I recognize that it went through at, yep, at -3 for a y-intercept. So, totally looks like this, right? Yeah, that's pretty good. I didn't really plot any points besides that y-intercept. You guys should plot at least a few points. The domain is an easy question. It's always -infinity to infinity. The range will be an easy question once you remember that the range is going to start, in this case, at the horizontal asymptote. So the range starts at -4, but because it's an asymptote, you cannot use a bracket on it. So that would be another time when I should recognize, like, oh my gosh, that -4 shows up again. It's going to show up as the asymptote, the vertical shift. It's going to show up right here on the range. And it's going to show up again here on end behavior. So remember, end behavior, this part can always be filled out because I want, ooh, that's ugly. I want left and right end behavior. So -infinity for x is fancy talk for left. This is fancy talk for right. So on the left side, the function is trying to approach the asymptote height. So that's -4. And then on the right side, it's going up, up, up. And we say that by saying infinity. So once again, that -4 shows up again. And that's what I really want you guys to concentrate on. Oh, not that. If you feel like you're stuck on this question and you're not sure if everything's quite right, whenever you highlight this -4 or whatever that number is, it should show up boom, 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 a whole bunch of places. Now sometimes that number is a 0, so keep that in mind. If there's nothing off to the side here, like if it's, you know, 3/5 to the x power, and that's it, then the number you're highlighting in that case is a 0, so that the asymptote is going to be at y equals 0. So keep that in mind. I'm not saying it's going to show up like that, but sometimes it does. All right, so here's some new stuff as well. We have some application questions. Sometimes we're on the home screen of the calculator, and sometimes we're in y equals, so we got to be careful. You do get formulas on this question. On your test, it's going to say use the formula y equals a, and then it's going to say plus or minus r to the t power. Now it's up to you whether you're using the plus or the minus. So remember, this a value is the original amount. So if your city originally has 816,000 people, that's going to go right there. And then it's increasing 2%. So that's going to help me with the r, and also the fact that it's going to be a plus sign because it's increasing. And they want to know the population after 12 years. So that right there is going to be time, t. So here we go. In the home screen of your calculator, because we don't actually have to predict anything, you're going to type 816,000 and then 1 plus 0.02 and then up in the exponent to the 12 years because it's going to be 12 years later. Now these are people, so you're going to want to round appropriately for this question, guys. You don't want to round to a portion of a person. That's kind of weird. So it's about 1,034,885 people when you round. So you can put an about symbol, an approximate symbol. So home screen of the calculator, type this in, there you go. I'm going to let you do 5B on your own. Alright, 6A, we have an antique car, and it's increasing. There's a clue about the rate, increasing 7.2% per year. The current price of the car is $5,600. When will the car reach a price above $10,000? So since they want you to predict something, that means you're going to have to use the y equals and the table. So first thing we're going to have to do is write up something to go into our y1. So the initial amount of the car is $5,600. And then it's increasing, so 1 plus 7.2%, which you got to divide that by 100 or move it over twice, so 0.072. And then remember, because we're predicting, you're going to leave time as an unknown quantity. It's a variable. Okay, so I think I have this on my calculator. Let me go find it. Maybe. Alright, so turn this one off. Yep. And then I'll go turn this one on. So notice x is a variable because it's going to change with the table. And then we're going to go to the table, and we're trying to predict when it hits over 10,000. So if I'm looking at the amount of the car right here, so between 8 and 9 years. So you can say after 8 years, you can say between 8 and 9 years. We're just looking for an approximate answer from you today on Algebra 2 questions. So between 8 and 9 years. But you're going to look at your table. Alright, so that shouldn't be too bad. It is the hard part of that question is programming it properly. If you don't have the right function, you're going to have trouble. Alright, okay, the next one, 7. You are going to have a formula given to you. It's going to be that compounding formula. So it's going to say A equals P, and then, oops, move my screen around. Okay, or not. 1 plus R over N to the NT power. So, P, the initial amount, is the principal. That is $3,200. So we're going to start with $3,200 as the initial amount, and then open parenthesis, and then you have 1 plus the rate, which is 2.5%. So be careful, you got to write that as 0.025. Either divide it by 100 or move the decimal point over twice. Now this time you're collecting interest a certain amount every year. In this case, it's daily. So that's the N that you need to use. And every year there's 300, we'll just say 365 days, even though that's not technically right. It's 365 and a quarter, I believe, but whatever. And then up in the exponent, you might have to open a parenthesis if you're on an older calculator, but on the newer ones you don't have to. The N shows up again, 365. And then you're going to multiply it by how much time has gone by, which is right here, T. So 5 years. So that's on the home screen because you're not predicting anything. You're just calculating. So that, and this is money, so let's round appropriately this time, guys. We have, what? 3,000, so dollars. 3,626, and because it's money, round to the nearest cent. 3,626 and 6 cents. Alright, 8A. It's this predictor thing, huh? How long will it take for it to... So anytime you don't know, you have to predict the time. That means you're going to use your table. So in this question, you're going to use the y equals, and you're going to look at your table. Now this question's a bit tricky because it just says you have some random amount of money, and you want your money to double. So my formula for y1, you can use any amount of money you want. So use any initial value p. So I like to use $100 because I think it's easy for me to do math with $100. So that's p in my case, and then you're going to multiply it by the number e, which is a weird number like pi, and then up in the exponent, r times t. So the interest rate is 3%, so 0.03. And then remember how we don't know time? You're going to have to leave it as a variable because that means I don't know it. So this gets programmed into y1, and then you're going to go look at your table, and then you want your money to double. So for me, I'm going to look for, so if I had $100 and I doubled it, I'm going to look for $200. All right, here we go. I think I have this in my calculator too. Yeah. All right, turn the other one off. Maybe. There we go. Turn that one on. And then look. Okay, so $200. I'm looking in the Y column. I'm moving the X column, but I'm looking in the Y's for a while. It does pick up here at the end, so never fear. So between 23 and 24 years. So that's what I'm going to write down. And regardless of how much money, so the answer here is between, regardless of how much money you invested, you would have got that same answer. So don't worry, if you decided to invest $1, it's still going to work out. All right, this is an old topic, but it's back as promised. We are finding inverses. So two-step process, the first thing you need to do is to switch your x and y. And then you need to solve for y. So it's written in fancy function notation, right? So that means this is really a y equals 8x minus 5. So step 1, where you switch the x and y around, this becomes x equals 8y minus 5. And then you're going to solve for y. So how about we add the 5 over. So you have x plus 5 equals 8y. And then one more step, I would just divide everything by 8. So you can either divide the whole thing by 8, like this, which is totally fine. So if you wrote down x plus 5, all of it divided by 8, that's okay. Or an even better way to write that, in my opinion, would be 1/8 x plus 5/8. That would be a little better notation for that. So I'm good with either. Those of you moving on to pre-calc in the future, you might want to think about using this notation instead. Okay, some properties of inverses. Remember, this was on a worksheet from your homework check. Domain and range, switch, or reverse, you can say. A function and its inverse are the same. Well, sometimes they are. Not usually, but sometimes. Can you have a function whose inverse is not a function? Yes, that can totally happen if the horizontal line test doesn't get passed. So if the original passes the horizontal line test, then the inverse is a function. And then they are reflections of each other across the line, y equals x. So those are all properties we want to kind of study for this test. And then we're going to put those thoughts together here. We're going to draw an example of an original function. So it has to pass the vertical line test for the original to be a function, whose inverse is also a function. So if the inverse is also a function, this thing we draw also has to pass the horizontal line test. So there's a lot of things you could draw. You could just draw a line. That would work. Make sure it's not vertical or horizontal though. You could draw a weird little squiggly thing that goes like this. There's several things you can draw. But on this next question, I still need an original function, so you need to pass the vertical line test. But I need the inverse to not be a function, so I need it to fail the horizontal line test. Again, lots of things you could draw. Most common one that I see from you guys is our friend the parabola. He passes the vertical line test, but he really badly fails the horizontal line test. All right, that is summative number 4. I hope for some better scores on those 2 repeater sections, and then some solid scores on this applications and graphing of exponential growth and decay. I think it shows good promise, guys. Good luck, everybody.